Okay, we're on page 110 today. Yes, 110. So we have talked about slope-intercept form, and we talked about point-slope form as options to be able to represent a linear function. Today, we're going to talk about one more option that we have to represent a linear function. Okay, so slope-intercept form was helpful and an easy option when we knew the slope and we knew the y-intercept. When we had a problem in context, if I knew an initial value and a rate of change, that's where we talked about slope-intercept form. Point-slope form, which we talked about earlier this week, was helpful if we knew a point on the graph that wasn't the y-intercept and we knew the slope. That was good for point-slope. In context, like what we looked at yesterday, if I knew a rate of change and some value that just wasn't the initial value. So yesterday, I believe we looked at a problem that was something like after 6 hours, our hiker had climbed 700 feet, something like that. So we knew a point on the graph, but we didn't know maybe the starting position. Today, we're going to look at problems where we don't know a rate of change or a slope, and we don't know a specific point on the graph. We've got some other information about how our two variables are interacting, but it's not a slope, and we don't have a point. So that's why we're going to talk about something called standard form today. So for our first example, it says to get snacks for a class trip, Claire went to the bulk section of the grocery store. So do you guys remember, like, pre-COVID? I know they took it out of my local grocery store. Pre-COVID, there used to be a section where you could buy, like, there were like big bins and you could just scoop like as much like granola as you wanted, or like rice combinations, or like that bulk section, right? Or like pistachios. And so you would take however much you wanted and scoop it into a bag. And then at my grocery store, there was a scale there, and you would punch in the like code for the product, and it printed. Yeah, kind of like that. Or they used to do like candies sometimes, like you could, if you wanted like a lot of gummy worms or something. And so you could, for mine, they had a scale right there and it printed a label for you to scan. But I know at some grocery stores you would like write the product number on the bag and they'd weigh it at the cash register. But we all know what we're talking about, right? Okay. So that's where she's going to buy snacks, and it says she could buy any quantity of a product. So that's important for this problem, any quantity. So I could buy exactly 1 pound of granola or gummy worms, or I could say I want like this much and scoop however much I want into a bag. And if it's exactly 2 pounds, great. If it's 1.783 pounds, that's fine too. Does that make sense? So the prices are always listed per pound for those things, but I don't have to buy in exactly 1 pound increments, okay? Any quantity is fine. So she purchased some almonds for $6 per pound and M&Ms for $9 per pound, and she ended up spending $75 before tax, okay? A couple of you are making the same face that some of my earlier students made, because only in a math problem does somebody spend $75 on M&Ms and almonds. Yeah, it's like in grade school when you had a problem, it's like, Gerald went to the grocery store and bought 63 watermelons. No, Gerald, you don't need that many, or cantaloupes or whatever it was. Yeah, like we don't, that's too much fruit, right? You're gonna have some problems. That's too much. So I don't know if this trip is like a year long, and so we're buying all the almonds and M&Ms that we're gonna need, or if it's like 100 people that are going, but for whatever reason, we've spent $75 on almonds and M&Ms, okay? So we've got a couple of hypotheticals here. Let's say she bought 2 pounds of almonds. If she bought 2 pounds of almonds, how many pounds of M&Ms did she buy? Okay, we're actually going to work through this one together. Okay, so I know that we're talking about almonds to start. That's the information that we have at the beginning. I know I bought 2 pounds of almonds and they're $6 per pound. So I spent $12 on almonds, okay? I know I spent $75 total. So if I subtract off the almond money, that would give me $63 that we spent on M&Ms. Okay, $63 that we spent on M&Ms. Now, I don't want to know how much money I spent on M&Ms. What I want to know is how many pounds of M&Ms did she buy? So M&Ms are $9 per pound. And I bought, I don't know, some M&Ms for a total of $63. So to figure out how many pounds of M&Ms I bought, I'm going to divide both sides by 9. And that would tell me that I bought 7 pounds of M&Ms. You with me on this one? How we got there, right? We had some hoops to jump through, but we got there. I want you now to try number 2. It's a similar idea, but this time we're starting off with information about M&Ms, and I want you to tell me information about almonds. Okay, so give number 2 a try. So we're starting with information about M&Ms on this one. We're buying 1 pound of M&Ms, and they cost $9 per pound. So that means I spent $9 on M&Ms. I'm going to subtract that from my total, and that tells me that I spent $66 on almonds. So now almonds are $6 per pound. I'm not sure how many pounds I bought yet, but I know it costs $66. So I'm going to divide both sides by 6, and that tells me that I bought 11 pounds of almonds. We get 11 pounds? Okay. So these were set up kind of like hypotheticals. Well, if she bought 2 pounds of almonds, or if she bought 1 pound of M&Ms, or if I bought this, and we could keep doing this all day, right? If I bought this many pounds of almonds, or this many pounds of M&Ms, then how many did I buy of the other thing, okay? What would be nice is if we had a way to describe all of these things in one go, okay? One concise way. We do, and it's called a function, right? That's the point of functions, is that they give us all of these options in one neat little package. Now, I don't have a slope here, right? I don't have a point identified here. What I know is price per pound for almonds and price per pound for M&Ms, okay? I have these rates that apply to 2 different things. When I have a situation like this, I want to think standard form, okay? That's what we're talking about today, standard form, okay? So here's what standard form is going to look like. Okay, write an equation that describes our relationship between almonds and M&Ms. So my almonds are $6 per pound. So $6 for every pound of almonds that I buy. I'm going to use A to to represent pounds of almonds, and I'll define that down here. A is my pounds of almonds. And then I'm also buying M&Ms, and it's $9 per pound of M&Ms, and I'm going to use M for my M&Ms. So M is pounds of M&Ms. And I know that my total, so if I added these together, how much money I spent on almonds and how much money I spent on M&Ms, my total would be $75. That's a standard form equation. So I tend to, when I write standard form, I tend to use letters that represent whatever I'm talking about from the problem. So I use A for almonds and M's for M&Ms. If you want to go straight to X and Y, that's fine. Sometimes I get a little confused if I use X and Y right out of the gate. So that's why I use a lot of times letters for my problem. Mm-hmm. 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 Yeah, you are welcome to write your equation using whatever letters you like. I pick ones that make sense for the problem to me, because if I went straight to X and Y, I know myself, and I know I would get confused and I have to go back and label, well, this was X and this was Y, and so that's why I do it this way. Now, in just a second, I am going to go label an X and a Y, because on the graph, right, it's the X-axis and the Y-axis. We can't get away from that. But I like to set these up using variables that make sense for my problem. With me so far? With me for our equation? Okay. So now, let's take a look at a graph of this situation. Okay. So here's what I'm going to do really fast. My graph has an X-axis and a Y-axis, right? My X-axis is labeled pounds of almonds. So right above the almond numbers, I'm going to put an X. And then right above my pounds of M&Ms, the Y, I'm going to put a Y. So that's what I was talking about, how I'll go back and label with the X and Y in just a minute, based on how my graph is labeled. Okay. So here's a graph that represents our situation. Choose a point on the line and describe the meaning. Now, we can pick any point we want on the line, right? Anything on the line is fair game. But just to make things a little simpler on ourselves, I'm going to pick point A. It's a nice, easy point, 2, 7. And it says, describe the meaning of this point in terms of the problem. Now, you guys have gotten questions like this from me before, right? What does the point blah, blah, blah mean in the context of the situation? Okay, and so you got to tell me, well, 2 means this and 7 means this. So in the context of this situation, 2 is talking about how many pounds of almonds we bought. 2 pounds of almonds. And then 7, our Y value, would be how many pounds of M&Ms we bought. So 2 pounds of almonds and 7 pounds of M&Ms. There's something special, though, about 2 pounds of almonds and 7 pounds of M&Ms. That point is on the line. Okay, that's important. If it's on the line, I know something about 2 pounds of almonds and 7 pounds of M&Ms. What do I know? I know the cost. Since it's a point on the line, I know that this costs $75. And in fact, any point on the line would be an amount of M&Ms and almonds that cost $75. And because it said at the beginning that I can buy any quantity I want, it doesn't even have to be a nice point. So like right here would be like 4.5-ish pounds of almonds and 5 and maybe 1/4 pounds of M&Ms would cost $75. Any point on the line would be amounts of these things that cost $75. Now let's look at a point that's not on the line. So we could pick any point that we want, but let's pick one that's nice here. So D is labeled for us, 1, 1. This 1 is telling me what? This first one. Yeah, I got 1 pound of almonds and 1 pound of M&Ms. 1 pound of almonds and 1 pound of M&Ms. What do I know about 1 pound of almonds and 1 pound of M&Ms? Since that point is not on the line. Yeah, right? It's not going to be $75. $75 would be amounts that are on the line. Since this is not on the line, 1 pound of almonds and 1 pound of M&Ms does not cost $75. Questions for me so far? For whatever reason, sometimes because we've seen slope intercept form for forever, we're like slope intercept form is the only thing and it has to make sense. And for some people, that just maybe isn't a great option. So the nice thing about lines is that if slope intercept form never made sense for you, like we got all these other choices.
So when you write the standard equation, even though it's addition, you still have to write x before y?
No, you don't have to. So let's say I had decided to put the M&M stuff first and the almond stuff second. Then I would have had the Y thing first and the X thing second, and that's fine. Other questions for me so far? Okay, let's turn the page and let's look at another one. An art teacher is selling children's crafts. Necklaces cost $2.25 each and bracelets cost $1.50 each. Select all the combinations of necklaces and bracelets that the artist could sell for exactly $12. So I want you to give this a try. You know the price for every necklace and the price for every bracelet. I've given you different options here for amounts of each you could have sold. I want you to find the ones that cost exactly $12. You're probably going to want your calculator for this one. Okay, yeah, you can use your calculator on it. So take the next couple of minutes, figure out which of these would have cost exactly $12. So what I saw as I walked around were people typing in their calculators, or some of you even actually wrote this out on your papers, something like this. So what you were doing was, I know I bought 5 necklaces for $2.25, plus I bought 1 bracelet for $1.50. That was $12.75. That's not it. For the next one, 2 times 225 plus 5 times 150, that gave me 12. So B is an option. Okay. This look familiar? This look like what you were doing? Yeah, pretty much everybody. So what were the other options? We know B was $12. What else? Go ahead. D was an option. Somebody else give me another one. G was an option. Anything else? Nope, those three were it. What you were basically doing here was guess and check, right? Well, maybe this many bracelets and this many necklaces. Nope, maybe this many and this many. Yep, that one works. Maybe this and this. Right? And there's nothing wrong with guess and check, but what's a downside? It takes a while, right? It takes a little while. So again, wouldn't it be nice if we had sort of one concise way to represent all those possibilities? That we do, that's a function, right? So let's write a function for this scenario. Okay, write an equation that represents all possible combinations of necklaces and bracelets that could be sold for $12. Okay, so 225 is the cost for every necklace. I'm going to use N for number of necklaces. That makes sense to me. And then it's $1.50 for every bracelet. I'm going to use B to represent the number of bracelets that we're going to sell. And then the price for all my necklaces plus the cost for all my bracelets should be equal to $12. No, you don't have to put the $sign when you're writing your function. Okay, so there's my function here. Now, we're going to graph this. The graph was given to us on the last one. We're going to create the graph for this guy. And then again, my axes are already labeled. So just right next to my N and my B, I'm going to put whether it's X or Y. So necklaces is labeled on the X axis. So I'm going to put an X here. Bracelets is labeled on the Y. So I'm going to put a Y there. Just so I've got that sort of jotted down as I'm looking at graphing. Now, we said earlier that there's no slope in what I've gotten so far. There's not a particular point in the information I was given that I used to write this equation, which means there's no slope and no point represented in this equation as it stands right now. Without a point and without a slope, graphing's a little tricky because those are the things that we've used to graph so far, right? We've needed a point of some kind and a slope, and we don't have that here. Tomorrow, we're going to talk more about how to graph from standard form, just using what we're given in the equation. But for today, I want you to notice that we know some values that should be on that line, right? We know 2 necklaces and 5 bracelets equals $12. So does 4 necklaces and 2 bracelets, or no necklaces and 8 bracelets. That means that we have 3 points on the line. So I'm going to use those 3 points. I have 2, 5, because remember necklaces is our X, bracelets is our Y. I've got 4, 2, and we've got 0, 8. So we know 3 points that are on that line. We can graph using those points. So I'm going to plot those. 2, 5, 4, 2, and 0, 8. 3 points, so I can sketch my line. So it's going to look like this. Okay, something like that. Now, the y-intercept is one of the points that we use to create our graph, right? This guy right here, 0, 8. What does that point mean in terms of the context of our problem? What's that y-intercept going to mean? Go ahead.
So when the y is at 8, that means that's how many bracelets that's how many bracelets you can sell for $12 without any necklaces. Perfect.
I can sell 8 bracelets and no necklaces for $12. The no necklaces part is important. Okay. So 8 bracelets and no necklaces costs $12. That's a point on the line, so it costs $12. Now the x-intercept is not a point that we had. My sketch sort of shows it falling somewhere between 5 and 6. I'm going to double check that with the slope. So slope would be to get from one point to the next, 1, 2, 3, down 3, and then forward 2, -3/2. So I'm going to use my slope from this point to figure out if my next point would land here. So that would be 1, 2, 3, down, forward 2. Nope, not so much. So I'm going to be somewhere between 5 and 6 for that x-intercept. Now, what does that mean in the context of my problem?
It just means that basically it's almost the same thing as the line that with the number of necklaces you can sell outside and bracelets.
The number of necklaces that I could sell for exactly $12 if I sold no bracelets, right? Now, I want you to remember that we're not talking about like pounds of goods from the bulk aisle. This time we're talking about like necklaces and bracelets, right? Like different, it's a different idea here, okay? So since my x-intercept is gonna fall between 5 and 6, is that a value that makes sense for this problem? No, right? I can't go to the counter and say, I'd like as many necklaces as you can give me for exactly $12. And they'll say, okay, here's 5, and then let's take this one and cut it in half, and you can have 5.5 necklaces. No, that's not gonna do anybody any good, right? So what does that tell me? Can I spend exactly $12 on only necklaces?
No.
No, right? Because I'm in between 5 and 6. So we cannot spend exactly $12 on only necklaces. Not possible, not going to happen. Questions for me on this second example? Okay, we're going to stop there in our packet for today. Tomorrow, we're going to pick up looking more at graphing from standard form. For tonight, for homework, you guys are going to have an assignment on Delta Math, but I want to go through a couple of them with you to start, just to make sure we're all on the same page about what we're going to do. Okay? So I've got a problem pulled up here. It says Nina finds some nickels and some quarters under the couch cushions. How much money in cents does she have if she has 8 nickels and 6 quarters? How much money in cents does she have if she has n nickels and Q quarters? So every question that you guys will see is gonna be in this format, right? Everything you get is gonna be in this format. So it's gonna ask you something specific first, and then ask you for something general. Okay. So I like to jot down some notes as we go through these. So I'm talking about nickels and quarters. And it says, I want to know how much money I have. Well, I need to know how much a nickel is worth and a quarter is worth. Hopefully, we all are on the same page about a nickel being worth 5 cents and a quarter being worth 25. Okay, good. Okay. And then it says, how much money would I have if I had 8 nickels and 6 quarters? Well, if I've got 8 nickels, I want to do 5 times 8 to figure out how much money I have in nickels. And if I've got 6 quarters, I want to do 25 times 6 to figure out how much cents I have in quarters, right? So 5 times 8 is my money from nickels. 25 times 6 is my money from quarters. To get my total, I have to add those up, right? Okay, just like our M&Ms and almonds problem. So whatever I get from here, from adding up my money from my 8 nickels and my 6 quarters, that's what's going to go in the first box. So you're going to have some sort of concrete like number answer that goes in the first box. In the second box, you're going to give me an expression. So that's what the second question is asking. How much money in cents does she have if she has n nickels and 2 quarters? So let's say I don't know how many I found yet. I haven't counted them up. So I'm going to change the 8 to an N, and I'm going to change the 6 to a Q. And so what I'm going to type in that box is this expression, 5N plus 25Q. Does that make sense? What? No, no, you don't have to have that little dot.
And is there a space in there?
No. No, you shouldn't need any spaces in here. I gave myself lots of room to be able to like write numbers and change things as I was writing on the board. But this would be the expression that would go in your second box. Does that make sense? And so every problem is going to have this format. So I'll do one more with you guys. Okay. A school needs to buy new notebook and desktop computers for its computer lab. The notebook computers cost $300 each. The desktop computers, okay, notebook computers cost $300 each. I'm just jotting some notes down. The desktop computers cost $225 each. How many total computers would someone buy if they get 19 notebooks and 17 desktops? Now this one is tricky because they actually give me too much information, okay? So they gave me prices for these different types of computers, right? But then the question is, how many total computers am I buying? The question is not about cost, so I don't care how much each of these cost. That's what makes this one tricky. They gave me that information and I don't need it, okay? So how many total computers would someone buy if they get 19 notebooks and 17 desktops? Well, I'm just gonna add up 19 and 17. Does that make sense? I add up those two different types of computers that I bought to get my total. And that's what goes in the first box. And then in the second box, how many total computers would someone buy if they get N notebooks and D desktops? Well, the first time I just added up 19 and 17. So for the second one for our expression, we're just gonna add N and D. So that second box would be N plus D. Does that make sense? Okay. So that's what you're looking at for homework for tonight.